Oh, question number 7. This is one of the last set of questions. 4, 5, 6, and 7 are worth 4 points each. Okay, we've got a titration and we've got a burette with 2 readings. Now I'm going to read this, and it says we have 25 samples of an unknown monoprotic acid. So we have 25 mLs of acid. The readers said that one of the common errors in this problem was that people mixed up the acid and base in their calculations. So what I'll do is I'm going to make the acid red. I'll get my highlighter and I'll pick pink, and this is 25 mLs of my acid. That's going to remind me, I would write up here acid, or VA, volume of acid. In fact, let me put that in right now. This is my volume of acid. I'll pick red, and let me get a larger font for that. I'll make this about 16. That's going to be my VA. That I'll use in my calculation because this is a titration. I'll use my titration equation. And of course, this is my acid. Now, the student uses a solution of, here's my base. So I'll get my highlighter and I'll pick, let me get yellow for base. And again, I would, if you're really good at this, I'm going to say this is going to be my text. And yellow is not going to show up well, so I'll pick, let me pick gold. Okay, this is going to be my concentration of my base. This is going to be 0.100 molar, and of course the M will help me with that. So I've got a volume of acid, I've got a concentration of acid. We know the titration, Ca times Va equals Cb times Vb. Well, we've got a couple of these things, and right now we've got our base here in our burette. So we've got the titration with the volumes of my base that I have to read. I'll zoom in. Notice the numbers go from 5 to 6, so we're increasing. 5.1, 2, 3, 4, 5, 5.6, 5.7. It's in between. And in this case, they decided it was 5.65 mLs. You have to read in between the lines. If you didn't come up with the hundredths of an ml in your calculation, they would not have given you the point. They could have accepted 0.67, 0.63, just as long as you had a hundredths in here and it wasn't, it was approximately that. Tricky one here, again, we're pouring solution out, and a burette is nice in that it shows you your milliliters going down. So here we have 37, 37.5, so 3, 4, 37.1, 37.2, 37.3, and it looks like it's right there. So they chose 37.30, and if you had had 2.9 or 3.1 or 3.2, those would have been accepted, but you would have to show the hundredths of an ml. If it's reading tenths, in terms of the scale, you read between the lines, which is the hundredths. And they subtracted the two. Let me scroll out. And they showed the hundredths of an ml. 1 point for the correct volume, and if you did not have a hundredth here, they would have not given you the point. So remember, read between the lines. Reading scales is common on the exam. Now, this right now I'm going to highlight. This is going to be the volume of my base. Again, the most common error they said on this was that people mixed up the volumes and concentrations in their calculation. They show the calculation using this equation. I use concentration rather than M. But here it is: concentration of acid, volume of acid, concentration of base, volume of base. Make sure you get them right. Don't confuse them. This is 31.65 volume of base. The concentration that they gave for the base was 0.110. You know the volume of acid, 25.0, and that's it. Now they changed these to liters, but you could have used 31.65 milliliters, and 25.0 milliliters also. Ideally, because they gave you the volume of the acid just to the tenths, this would have 3 sig digs, but I'm quite sure the only time that they would penalize you for sig digs would be this. So if you put in 4 sig digs, fine. I'm not sure if they'd accept 2, but that'd be pushing it. So we've got 1 point. Again, just show a setup. You don't have to show it. I think it's ideal to show the entire calculation, because if you set it up right and put it incorrectly in your calculator, they might give you the point. I don't think they should do it, but I've heard that they do. So 1, 2, we've got 4 points. And the next question. On the second trial, a student accidentally added more sodium hydroxide to the flask than was needed to reach the endpoint. So extra NaOH. Would this error increase, decrease, or have no effect? They give a long answer. I mean, let's see how many sentences. We got quite a few words. A couple of sentences. When you run into a error problem where they tell you the student did something wrong, go back to your calculations. What I would do is I would say, okay, I would write down right here, instead of 31.25, I would, let me get it, no, I'll use the text. I would say, oh, let me just make that 40. That's a real error. mLs of the base. And that's what he said, more. And then I'd redo the calculation and show the new concentration. That would be a lot faster than having to write all this and think it out. Just put in 40 mLs and see what you get. Now, don't forget, you have to have a direct answer to the question. You can't just show your justification. You would have, even if you showed what the concentration would be with 40 mLs of sodium hydroxide, if you did not directly say the error would increase the calculated acid concentration, you have to say the error would increase the acid concentration, period. You need that for this point. Then a justification, I would use a calculation. They said common error, people overthought this using pH and all the rest of that jazz. No need for that. A justification, just give some data, say, okay, 40 mLs increases the calculation for the concentration of the acid. Show the calculation, and I think that'll do it. Okay, 4 points. Important one here is, I think the two important things, because you know this calculation, is to read between the lines to show the hundredth, and the other is to answer the question. Let me get rid of this. Cut. And the best way for doing an error in a lab situation is go back to the calculation and see what you get when you include that error in your calculation. Okay, that was it.